Given question, draw shear force diagram and bending moment diagram. Find the location of point where shear force is 0. Also find the value of maximum bending moment.
Given diagram is simply supported beam which carries uniformly distributed load as well as uniformly varying load. If we observe this diagram, we will make here one construction line CD. Then the area ABCD is known as uniformly distributed load and the load is equal to 30 kN per meter. And the remaining area CDE is known as uniformly varying load, which the load varies from 0 up to 100 kN per meter. Now we will calculate the total load in UDL as well as UVL. So first we will move to the uniformly distributed load where the load is equal to 30 kN per meter. That means for 1 meter load is equal to 30 kN. But the span, total span is mentioned in the question 4 meter. So what is this load? So load is equal to 30 multiplied by 4. 120 kilonewton. Now we will move to the next uniformly varying load. So this load will vary from 0 to 100 kilonewton per meter. So how to calculate the total load? So if we observe there is the shape of triangle CDE. So total load, that means area of triangle CDE. So total load is equal to area of triangle CDE, and which is equal to half multiplied by base CD. So base CD is 4 multiplied by height DE, and that is equal to 100. So when we calculate this, 200 kilonewton. So this is the total load. Now to draw the shear force diagram and bending moment diagram, we have to first show the free body diagram. So this is the simply supported beam where the supports are given at end A and B. So we will show the reactions at point A and B, that is RA and RB, in vertically upward direction. Now next we will plot uniformly distributed load. So where is the point of application of this load, or we can say center of gravity of this load? So for the uniformly distributed load, the load is applied at the center point. So here is the center point and load is 120 kilonewton. So here the distance is 2 meter and 2 meter on both the sides. Now what about the uniformly varying load, where the load is equal to 200 kilonewton. Now for this 200 kilonewton, we have to first find out the maximum load point and minimum load point. So if we observe, maximum load point is above this point A and minimum load point is above this point B. So the point of application of this load is equal to 1 by 3 multiplied by total distance from this maximum load. So we have to show that. So what is this distance? 1 by 3 multiplied by this total span 4, that is equal to 4 by 3, and remaining distance is equal to 2 by 3 multiplied by 4, that is equal to 8 by 3, and this distance is from minimum load. So from maximum load, that is from this point A, we have to select the distance 4 by 3. So here this distance is 4 by 3 and remaining distance is 8 by 3. So this is the point of application of load, and this is equal to 200 kilonewton. So this is the free body diagram. Now next point, we have to find out the unknown values of RA and RB. So how to find out? So for that we will consider the system is in equilibrium. So when the system is in equilibrium, then we can say that summation of all vertical forces is equal to 0, summation of all horizontal forces is equal to 0, and summation of moments of all forces about any point is equal to 0. So first we will apply summation of all vertical forces. is equal to 0. Now this RA and RB in upward direction and this 200 and 120 kilonewton in downward direction. So we can say that RA plus RB is equal to 200 plus 120. So which is equal to 320 kilonewton. So this is the equation number 1. Now there is no any horizontal force, so we will take summation of moment of all forces about any point. So if we observe here RA and RB both are unknown, so we can take the moment about point A or B. So for this question we will take summation of moments of all forces about point A is equal to 0. Now with the help of compass we will solve this. So for this direction is important. For clockwise direction we will use positive sign, and for the anti-clockwise direction we will use negative sign. Now if I move the compass in the direction of 200 kilonewton force about point A, then it is in clockwise direction. So how to write moment? That is this 200 multiplied by distance in between A and this 200, and this distance is equal to 4 by 3, and it is having positive sign. Now next we will move to 120 kilonewton. So again I will move the compass about point A in the direction of 120. Then it is having clockwise direction. So plus 120 multiplied by distance in between A and this, that is equal to 2. Now next RB. So if I move the compass about A in the direction of RB, then it is anti-clockwise direction. So minus RB multiplied by the distance in between A and B, that is 4, is equal to 0. So we will solve this and then we can find out the values of RA and RB. Next step is to calculate shear force. It is the summation of forces either on the left hand side or on the right hand side of the selected section. In this question, we will consider the summation of forces which are on the right hand side. If we observe the sign convention, then this is the section, and if the forces on right hand side is with downward direction, then use positive sign, and if these forces in upward direction, then use negative sign. We have to mention these sign conventions in the answer sheet. We will calculate shear force at any distance x where the load is 0 kilonewton. Now if we observe in triangle CDE, here from at this point C, load is 0 kilonewton. So we will consider any distance x from this end C. Now how to calculate the shear force at a distance x? So I will show here one vertical line, that is the section XX. Here is the section XX. Now for this uniformly varying load, this point of intersection, we will say this point will be point F and this point will be point G. Now we have to find out the rate of loading for this GF line. So we don't know what is the rate of loading, because rate of loading for this E to D is 100 kilonewton per meter. Then at point C, rate of loading is 0. So how to calculate the rate of loading along the section XX? So for that we will consider two similar triangles. So one triangle is CDE, from triangle CDE, and second triangle CFG. Now we will take the ratio of base to the height. So for the first triangle, base is CD divided by height is DE is equal to. Now for the second triangle, base is CF and height is FG. Now we will put the value. So value of CD is known, that is 4 meter. DE, so DE is 100 kilonewton per meter, is equal to CF. CF is equal to X, and FG we have to find out. So how to calculate this? So therefore FG is equal to, so it is equal to 100x by 4, and that is equal to 25x. So this is the rate of loading. So we have to mention this. So I will mention here the rate of loading 25x. Now we will find out the formula to calculate shear force at any distance x. For that we have to draw the free body diagram. So here we will show the end C as well as end F, and the distance in between C and F is x. We have to also show the reaction at point C, that is the vertical reaction RB, which is equal to 126.6. Now if we observe, in between C and F there are two types of load. First one is uniformly distributed load. So how to calculate the uniformly distributed load? So its a magnitude is given 30 kilonewton per meter. That means for 1 meter load is 30 kilonewton. So total distance x is given. So 30 kilonewton for 1 meter, and distance is given x meter. So we have to find out this load. So it is equal to, by cross multiplication, it is equal to 30x kilonewton. So we have to show this. So 30x we have to show with point of application of load or center of gravity point. So for this uniformly distributed load, this point of application of load is at the center, and its a magnitude is 30x, and we will show it is at the middle point. That means here x by 2 distance on both the sides. Now we will move to the next, uniformly varying load. So for this uniformly varying load, if we observe the triangle CFG, then load varies from 0 up to 25x. So how to calculate the total load? So total load is equal to area of triangle CFG, so which is equal to half multiplied by base. Base is FC, that is x, multiplied by height. Height is FG, that is 25x. So if we calculate this, then we will get 25x square by 2. So this is the total load, and where is the point of application of load? Now if we observe this point F, so it is with maximum load, and point C is with minimum load. So from maximum load we have to take the distance 1 by 3 multiplied by the total span x. So I will select here the distance, that is x by 3, and remaining distance, that is from minimum load, it is 2 by 3 multiplied by total span x, that is equal to 2x by 3. So here is the point of application of load, and this load is equal to 25x square by 2. From this free body diagram, we will write the formula to calculate shear force at any distance x. So we will take the summation of forces which are on the right hand side. So here is the distance x up to point F, and there are 3 forces on the right hand side. So on right hand side, if force is in upward direction, then use negative sign. So I will take here minus 126.6, then here this is the downward direction, plus 30x, and this is also in downward direction. So 25 by 2 is equal to 12.5x square. So I will take plus 12.5x square. So this is the formula to calculate shear force at any distance x. So we know that at point B, x is equal to 0. So when we put x is equal to 0, then we get the value of shear force at point B. And at point A, x is equal to 4 meters. So when we put x is equal to 4 meters, then we will get the value of shear force at point A. Now within the span of this AB, we will take x is equal to 2 meter, x is equal to 3 meter, and we will calculate the value of shear force. Now we will move to the next for the bending moment at any distance x. So we will use these sign conventions. So on right hand side, if the moment is in anti-clockwise direction, use positive sign, and on the right hand side, if the moment is in clockwise direction, use negative sign. So how to calculate this? Now here this point F is at a distance x. Now if I move the compass about point F in the direction of RB, then we will get the anti-clockwise direction. So we have to use positive sign. So plus 126.6 multiplied by the distance, that is x. Then we will move to the next force, 30x. If I move the compass about point F, then we will get clockwise direction. So we will use minus sign, minus 30x multiplied by the distance. So this distance is x by 2. So I will simplify this, 30x multiplied by x by 2. That means it is equal to 15x square. So I will directly write here 15x square. Now next is 25x square by 2, or we can say 12.5x square, and if I move the compass, then it is in clockwise direction. So we will use negative sign. So minus 25x square by 2 multiplied by the distance x by 3. So we can say that it is 12.5 by 3x cube. 12.5 by 3x cube. So this is the formula to calculate bending moment at any distance x. So we can put the value of x is equal to 0, x is equal to 2 meter, x is equal to 3 meter, x is equal to 4 meter, and we will calculate the values of bending moment at different points. To draw shear force diagram and bending moment diagram, we have to first draw one baseline. We will plot all the positive values in upward direction and all the negative values in downward direction. So here is the calculation for shear force and bending moment for the values x is equal to 0, 1, 2, 3 and 4. So we have to draw here the lines at x is equal to 0, 1, 2, 3 and 4 meter. So for the value x is equal to 0, shear force is minus 126.6. So because of this negative sign, we will plot this value in the downward direction. So here I will plot 126.6. Now next, as x is equal to 1, it is 84.1. So because of the minus sign, we will plot here 84.1. Then next is at x is equal to 2, it is 16.6. So I will plot here 16.6. At x is equal to 3, it is 75.9. So it is having positive sign. So I will plot this in upward direction. So its a value is 75.9, and next is 193.4. So I will plot here 193.4. Now we will move to the bending moment. So I have calculated here for x is equal to 0, 0. So this is the point B where x is equal to 0. So I will plot here the value 0. Then it is 107.4. So I will plot here one value 107.4. Next is 159.8. So I will plot here 159.8. Then next is 132.3. So I will plot here 132.3, and next one is 0. Now first we will complete the shear force diagram. So I will connect all these points. If we observe the shear force diagram, then it intersects the baseline where the SF value, that is shear force value, is equal to 0. Now we have to find out the distance of this point from the right hand side, because we have formula to calculate the shear force at any distance x from this right hand side. So if we take this x distance where SF value is equal to 0, then how to calculate this x? So we have formula SFX is equal to. Now when we put this formula is equal to 0, then we will get this value. So when we put this, then we will get the equation 12.5x square plus 30x minus 126.6 is equal to 0. So this is the equation in the form of ax square plus bx plus c is equal to 0. So value of a, that is coefficient of x square, is plus 12.5, b is plus 30, c is minus 126.6. So how to find out the value of x? So we have formula. X is equal to minus b plus minus under root of b square minus 4ac divided by 2a. So we will get two values. One is positive value and one is negative values because of plus and minus sign. So we will consider only positive value, and x is equal to 2.2 meters. So we will plot here the distance, that is x is equal to 2.2 meters from this right hand side. Now at this distance x is equal to 2.2 meter, we get the maximum bending moment. So how to calculate this? So in the bending moment formula we will put x is equal to 2.2 and then we will get the maximum value of bending moment. So when we put x is equal to 2.2 in this formula, then we will get bending moment is equal to 161.7 kilonewton meter. Now we will plot this. So if we observe, here is the line we have to show, that is passing through this point, and now on this line we will put the value 161.7. Now we will connect all these points and we will complete the bending moment diagram. So this is the point with maximum bending moment.